All right, let's do example 11. 2 plus 2 equals 5 for large values of 2. Okay, true story, right? Find the coordinate of any horizontal tangent and find the equation of any horizontal asymptotes. So 2 plus 2 equals 5 is from George Orwell's book, 1984. Have y'all read that yet? Is that a required reading? It's a really good book. It's a really good book. It's a must read. That's one of those classics that I would say is a must read. Yeah. Well, it's kind of meant to be like a joke, like Big Brother is telling you what to do. 2 plus 2 equals 5 for large values of 2. But it actually is true, right? If you look at 2.4 plus 2.4, that equals 4.8. And if you round, right, if you round both sides, you get 2 plus 2 equals 5. So it's not untrue. Yeah. All right. Anyway, horizontal tangent lines versus horizontal asymptotes. That's just kind of like a fun after lunch thing. They're different, but they're both horizontal. Yes. Yeah. So let's see. Let's do the tangent line first. To find a horizontal tangent line, what do we know about a horizontal tangent line? How do we find those? Very good. It's where the derivative is 0. All right. So that gives you your plan of attack. I need to find the derivative, set it equal to 0, and solve. All right. So g of x is blob squared. Blob squared. So let's just go ahead and use the chain rule, right? G prime of x is 2 blob to the first. And we write the blob in there. And you're like, oh, look, there's more than plain old x in there. There's a blob. So chain rule times the derivative of the blob, which is the derivative of arctangent, 1 over x squared plus 1 or x1 plus x squared, either one. Chain rule, right? Now, because we're going to use it, let's go ahead and simplify it. This is really over 1. This is really over 1. So if I multiply straight through, I get 2 arctangent of x all over 1 plus x squared. I get a single ratio. Nice. Now, for horizontal tangents, you have to show the equation you're solving. So we'll set it equals 0. You can do that right there. If you're using it more than once, like when we get to chapter 3, bless you, we find critical values, we'll use it more than once. But if we're just finding horizontal tangent lines, that's when it's 0. So we'll set the whole thing equals 0 right there. And now we will not multiply both sides by 1 plus x squared. No, no. We will say, though, that a fraction equals 0, what? When what's 0? The top or the bottom? When the top is 0. So you end up with pretty much the same thing that you would get if you had multiplied both sides by 1 plus x squared, but that's not how we got it. Because multiplying both sides by 1 plus x squared essentially eliminates it. We're getting it kind of by a theory. All right. Now we got to solve for x. So let's start peeling back the layers. How do I undo multiplying by 2? Divide by 2 on both sides. So I get arctangent of x equals 0 divided by 2, which is 0. How do I unarctangent something? What's the inverse operation of inverse tangent? Tangent, right? Again, tangent and arctangent, or tangent and inverse tangents, are inverses of each other. So if you want to show taking the tangent of both sides, you can. You would say it's not required. I'll just put a little asterisk here. It would be tangent of the left side equals tangent of the right side. And then you would just rewrite it. It has to go in the front. It's an operation. So you'd have to put it in the front. And then what happens on the left? What is tangent of arctangent of x when you compose two inverse functions back to back? They undo each other. And now it's unit circle time, everybody. Everybody's favorite time. What time is it, boys and girls? It's unit circle time. What is tangent of 0? 0. Yeah, kind of anticlimactic. Yeah, 0. And that's 0 radians, right? So it says to find the coordinate. Co means sharing. So how do I find the corresponding y value? Plug it back into the original g of x, because that's your y value machine. So, comma, g has a horizontal tangent. This is answering the question, right? At 0, comma, and then if I do g of 0, that would be arctangent of 0 squared. All right, and just plug it in for x. All right, and do all your work, and then always at the end answer the question. And get in the habit of like using a complete sentence. It's very nice. Now, if this were a free response, you could stop there. Arctangent of 0 squared is a non-simplified exact answer. Yeah. But if it were a multiple choice question, oh, booger. We wouldn't have to write the sentence, but let's see if we could do that. It's not unit circle time, it's time circle unit now, right? Well, it's time circle unit, everybody, because we got to do the unit circle in reverse. So when you say arctangent of 0, the easiest way to answer that is tangent of what angle gives you 0? And the answer is 0, right? But what about what about pi? What's tangent of pi? It's also 0. What about tangent of 2 pi? Also 0. Dang it. So if I'm trying to find the angle whose tangent of 0, and there's infinitely many of them, which one do I use? You use the one that's in the range of the function. We call it the principal value range. It has to be between negative pi halves and pi halves. So just like arc sine, if you take the inverse tangent of a positive ratio, you're going to end up with a positive acute angle between 0 and pi halves. And if you take the inverse tangent of a negative ratio, you're going to end up in quadrant 4, but by going there clockwise, a negative acute angle. So which one of those, 0 pi, 2 pi, 3 pi, is in the range here? 0 is right there. Yeah, pi is up there. That's on the next branch going up. So it is nice to know the PVRs, principal value ranges. I can mention that right here. Arc sine and arc tangent are kind of the same. The only difference is arc sine includes the endpoints and arc tangent does not. That's really the only difference. Okay. Yeah, arc tangent has it open. I'll say open, and arc sine has closed endpoints. That's really the only difference. And then arc cosine might show up. Arc cosine has 2 C's. It's not the half moon, it's the sun on the horizon. Yeah. So it looks like this. The rising sun. Yeah. The rising cosun. Whatever. So from 0 to pi. So positive, negative. So if you take the what's nice is all of them have a first quadrant PVR. So when in doubt, if you're taking the inverse trig of something, just go with the quadrant 1 angle if it lives there. Okay. The thing that's tricky is if you have a negative ratio. For arc sine and arc tangent, it's going to be a negative acute angle. Arc cosine, it's going to be a positive obtuse angle. Okay. So anyway, those are the only ones that really, it's worth kind of brushing up with those. So anyway, coming back down to here, simplifying, arctangent of 0 is 0. And what's 0 squared? 0. So really at the origin. This function has a horizontal tangent at the origin. Yeah. We should put equals or just write it there. Yeah. Okay. And now we want to know where it has a horizontal asymptote. Horizontal asymptote, does that involve calculus? It doesn't involve the derivative. How do we find horizontal asymptote? Remember, horizontal asymptote is an end behavior asymptote. What's that? Well, yeah, you can find it if you have a ratio of two polynomials. You can see which one grows faster. But a horizontal asymptote, like a slant asymptote, it could be the leading coefficient. It's an end behavior asymptote. That's what I'm trying to get at. It's an end behavior asymptote. And to find end behavior asymptotes, it's not a discontinuity. It's an end behavior asymptote. And the analysis is always this, right? The limit as x goes to negative infinity of the function, and the limit as x goes to positive infinity of the function. That's how we show the analysis, because by definition then, if either one of those two guys equals a finite y value, then by definition, there's a horizontal asymptote at y equals that finite y value, and vice versa. If you know there's a horizontal asymptote like at y equals 4, then one of those two, maybe both, have to equal 4. So let's go ahead and set that up, or it's g of x in this case. If you call something, unless there's more than one function, if you're only given one function and it's not named f of x, and you mistakenly call it f of x, it's not going to be a point deduction. All right, let's go ahead and plug it in there then. The limit as x goes to negative infinity, really, of arctangent of x squared. And the limit as x goes to positive infinity of arctangent of x squared. So remember, this is composition, right? It's a sequence of events. You have the arctangent going first and then squaring it. So we can take the limits inside, if you remember that. So if you do this, this is what it would look like. Take the limit inside, and you get the limit as x goes to negative infinity of arctangent of x. And over here, you can take the limit inside, and you get parentheses, the limit as x goes to infinity of arctangent of x squared. When we had the properties of limits, that's like the last one we used. Inputs become outputs, and those new outputs become the new inputs. So you can put a limit in front of every single variable piece, evaluate them individually, and then combine the results. Now that's helpful because I don't really know what the graph of arctangent squared necessarily looks like, but I did memorize the graph of arctangent of x, right? So what would that limit be? As x goes out to the left, arctangent of x approaches what? Negative pi halves. Very good. Negative pi halves. It gets closer and closer to negative pi halves. And as you go out to the right, it gets closer and closer to pi halves. Good, good, good. See, that's why you got to know that graph. It shows up. It'll show up again later when we do L'Hopital's rule. Now, free response, you can walk away right there if you have parentheses in place. What if you forgot parentheses and you said negative pi halves squared like that? How does that look? That looks gross. That looks disgusting. I mean, like, what are you trying to square there, dude? Or is that just a floating two? All right, so parentheses. Now, if you squared it, negative pi times negative pi is positive pi squared. And on the bottom, 2 squared is 4. And oh, look, they're both the same. So does this function g of x have a horizontal asymptote? Yes, let's put it down here. So g of x has a HA at y equals pi squared fourths. There's only one. Because it's only one number, and it affects the graph on both sides. Now, we could probably come up with a graph of arctangent of x squared if you think about it, right? I'll leave it there. If you sketch the graph of arc tangent, let's kind of sketch arctangent in there. I'll draw them in blue. This is pi halves. This is pi fourths, or negative pi halves, sorry. If I were to square all those y values, this is arctangent of x. If I were to square all those y values, what would happen to them? Well, pi halves, let's think about pi halves. Is pi halves bigger than 1 or smaller than 1? It's bigger than 1, right? So 1 might be somewhere in here, and negative 1 might be somewhere in there. If you square a number between 0 and 1, does it get bigger or smaller? It gets smaller, right? 1/2 squared is a fourth. So those numbers get smaller. But what happens if you square a number bigger than 1? It gets bigger. So this point should stay the same because 1 squared is 1. And then because of the symmetry, this point down here at negative 1, when you square it, should be 1. So this function is looking like it's going to have what type of symmetry? Y-axis symmetry, yeah. And it will. If you come up here and draw another asymptote just above it at pi squared fourths, you can now do this. It's going to do this. It's going to pass through here, and then it's going to bounce. It's going to go through there, and it's going to increase. Okay. And is that consistent with what we have already found? Look at the origin, right? What type of tangent line do we have there? Horizontal, right? And we already found that. We knew it was at the origin. So there you go. There's what the graph looks like. One asymptote only affects the graph on both sides. So this would be the graph of g of x. Nice. I'm going to shade him. Thanks for the help, arctangent of x. No problem. All right. Comments, questions, quips, quotes, concerns? Why was the Thanksgiving stew so darn expensive?
That's a great question.
Yeah, it's because it had 24 carats in it. 24 carats. Right. My family said you should quit telling Thanksgiving jokes. I said, I would if I could, but I can't quit cold turkey. Uh-huh. Uh-huh. Yeah. Yeah. Well, this is I was thinking of like stuffing. Some people call it stuffing, some people call it dressing. Then I was thinking of dressing. Then I thought of another joke that I know you've heard of before, right? Like, why did the eggs blush?
They saw the salad dressing.
Boom. They saw the salad dressing. Yeah. Very nice. All right. Let's move on to example 12. All right. Example 12. Now this, I don't know a lot of y'all's pre-cal background. I know a lot of y'all came from Miss Skurhawk, but because it was in pandemic time, I'm not sure if y'all did a lot of this. Huh? The pandemic, right? Remember the masks? Yeah. Rewrite tangent. Is that times? Tangent times arc cosine with x squared. I don't know how to read that.
Yeah, I can't read.
Someone help me. Tangent of arc cosine of x squared. Yeah, chain rule. There's 3 layers here, right? It says to rewrite it as an algebraic expression. What does an algebraic expression means? No trig. No trig.
No trig.
So I guess this is what they mean, right? Let t equal x, a equal y, n equals z, and that becomes x, y, z of, no, that's not right. That's not right. Oh, that's not right. Let's think about this, okay? Let's start on the inside, x squared. Does that x squared represent an angle or a ratio or an angle or a ratio or an angel? You ever misspelled angle and written angel and you're like, oh, thanks, dude.
I wrote my name
Angly. Is x squared an angel or a ratio? It's a ratio. Good. Because it follows an inverse trig. If it follows arc or inverse trig, it's a ratio. Okay. When you take the arc cosine then of the ratio, it's going to give you an angle theta. Now, it's not theta that we're interested in. We want to know what the tangent of that theta is. So when we take the tangent then of the resulting angle, our final result is a what? Angle or ratio? It's a ratio, okay? So we're starting with the ratio, and then we're going to end with a ratio. So what we're going to do is write the whole thing as a ratio so that we don't have to even get trig involved. If you plugged in an x like a 1 for somebody or 0 and say, here, tell me, they'd be like, I don't know any trig. But if you hand them like an expression that algebraically they can just plug and chug, they could probably handle it. So that's what we're going to do. So here's the first thing we do. We come up to the side and we draw a little first quadrant scenario. Give yourself a terminal ray that lands somewhere in quadrant 1. It's just something to draw on. All right, that's going to be my angle theta that I get when I take the arc cosine of x squared. Then we're going to do like all the good cops do on the streets of New York. They're going to drop a perp. Drop a perp to the nearest x-axis. That creates a reference triangle, yes? And that's what trig is. It gives you a way to talk about the ratio of any 2 sides. We have a ratio. It's x squared, but I can actually make it look more ratio-esque, right? If you want to come off to the side, you could say theta equals arc cosine of x squared over 1. Make it look more like a ratio if you want. And then how do you unarc cosine something? By taking the cosine of it. So we don't have to show that intermediate step. On the left, we get cosine of theta equals x squared over 1. Now that's something we're used to seeing, right? Cosine of theta is x squared over 1. So you don't have to do that if you just come up here and realize that that's x squared over 1. And because it follows arc cosine, it's a cosine ratio. Now, what was cosine's definition on the unit circle in terms of x, y, and r? X over r. Good. So x, y, r. You could use SOHCAHTOA, I guess, but it's better if we do x over r. Now, those x's are different x's, yes? The x squared is from our ratio. The X over R is just some third party reference. Okay. Party? I wasn't invited. X squared over 1. Okay, so let's go ahead and label our reference triangle. It must be X squared over 1, right? It's X over R. It's X over R. X squared over 1. Yes, yes? Okay, now we have two sides of the right triangle. Can we then find the third side? Yeah, by the P theorem, right? Let's call that Y temporarily. So we get 1 equals, or 1 squared equals X squared squared plus Y squared. Pythagorean theorem, right? X squared squared plus Y squared equals 1. Let's solve for Y. Solve for Y. You're going to get Y squared equals 1 minus X to the 4th. And now when you take the square root, you could do plus or minus, but we don't know which quadrant it's in. So if you stick with the PVR, you'll be fine if you go with the positive version. So you get 1 minus X to the 4th. So that's what this is. So now we really have all three sides of this reference triangle in terms of X, okay, for whatever theta is. Well, what's the final charge here? We want now the tangent of that angle. What's the definition of tangent in terms of X, Y, and R? Y over X. So I think we could do it now. Here we go. Let's just kind of write the whole thing again. Tangent of arc cosine, 2 C's, of X squared, close, close, is equal to the tangent of theta, which would be the square root of 1 minus X to the 4th. That's the vertical, Y, over the horizontal, X, which is X squared. And there it is. This is an identity. It's not worth memorizing like the Pythagorean identities or anything, but it is true for all values of X in the domain. I guess X can't be 0. It's true. It works. So the left side involves a sequence of trigonometric calculations. The right side is just a plug and shove, okay, which more people could handle, okay? And notice they look dramatically different, right? So when you have questions dealing with inverse trig like that, if they're double composition, you might prefer one version of it over another version. It's nice to have options, right? It's nice to have options. Yeah, like what's for dinner tonight? Well, here are your two options. Take it or leave it. Okay, that's good. Thanks. Options. I like options. Okay. All right. So I just did y'all do that in pre-cal? Do y'all remember doing that kind of? Okay. No. Okay. If you were in honors pre-cal with me, we never got to it. Yeah, we never got to it.
I wouldn't have remembered. So,
But if you were in Skurlock, you're a little bit further along. Okay.
I don't know. What? Did we do that?
Yes.
If the girls say yes, you did.
Yes.
Sorry, guys.
Yes.
Sorry, guys. Yeah. Okay. But now everybody gets it. Everybody understands how to do it. Okay. All right. So here's what I want you to do. I want you to find the derivative. This is the last one. Find the derivative of f of x equals cosine of inverse tangent of x over the square root of 6. This is why we do this. If you preview your answer choices, you're like, holy crap-a-moly. There's not a single bit of trig in any of the answer choices, is there? So you pick C and you hope for the best, right? If you were just to jump in and take the derivative using the chain rule, it would be f prime of x equal cosine of blob. Oh, I know, that's going to be negative sine of the blob times the derivative of the blob inverse tangent. Well, you're going to have inverse tangent, right? The blob. And now you're going to be like, well, that's my answer. That's not even going to be there. What gives? So in general, is it easier to simplify on the front end of things or the back end of things? Front end of things, right? Simplify early and often. So rather than take the derivative and then try to convert it all from trigonometric to algebraic, it's probably worth, changing it first. Now, if your answer choices had like trig in them, then there would be no need to convert it. So go ahead, and do we have time? Like 4 minutes? Yeah. Go ahead and do what we just did above for that right there. Come up with an algebraic expression. Okay, f of x equals. So this is your chance to use the previous question as a guide. And once we get that, then we're not going to be through. That's when we can actually start. BTW, your worksheet is going to be due Wednesday at 9 a.m. I just put it into Canvas. I know you've downloaded it from Corpy's World. Y'all don't say BTW though, right?
It's BT dubs now.
Oh, because by the way, if you say by the way, that's only 3 syllables. By the way, pretty short and sweet. But if you say BTW, that's more than 3. Yeah, so it's not really, it's cool. It sounds cooler, but hey, notice I brought my pepper grinder, my black pepper grinder up here from home. So now you have freshly ground salt and freshly ground pepper and freshly sealed olives. Yeah. Right. So black pepper. Yeah. The pepper was missing.
You said 9 a.m. for the worksheet?
Yeah. On Wednesday, not tomorrow. I'm going to go ahead and do it off to the side here with y'all. Thank you. F of x is in the top right corner. It's the cosine. Once you get all 3 sides, cosine, remember, is x over r. So the horizontal would be the square root of x from your labeling, and the hypotenuse is the square root. When you bring it to the top then and take the derivative, use the chain rule, you get to the answer a lot more quickly. So look before you leap, right? See y'all later. Have a fantastic rest of your day. Worksheets due Wednesday. Tomorrow we'll go over the test. I'll grade them tonight. The Monday night football game doesn't interest me. Yeah.
Okay, I was like, we don't have it.
Oh, sorry. Yeah. Television.
South Sanders Clemens.